Okay, guys, here is the last part for the lecture. And we're going to start from the chapter 25 right now, which induced current. And just for the continuity, let's start with this example here when I have the, here's the conductors listed by the rectangular here. And just for the simplicity, we just, we pointed to the one single positive charge. As we know, the conductors is contain the positive and negative charge. So here's the one times the first part we listed as a positive and second one to the negative. So see what the directions, what the force that applied for the when drag the conductor inside the magnetic field. So right now we have the magnetic field point to the page and we drag it to the velocity go to the right and want to identify the direction of the current. So basically we're gonna use the right hand rules to find it. So just pause the video and try to thinking what the direction of the force when we have positive charge. Okay, here we go. Here is the right hand rules that we apply. For the velocity or the time point to the right and the magnetic field point to the page, and you see the magnetic force point to the up. So from the positive charge, I have force pointed up. Here is that I have that magnetic force pointed up. Let's see the second situation was the same thing, the same situation with the magnetic field pointed into the page and we drag it to the right. And what happened with the negative charge in that case? The same thing, we're gonna use the right hand. We have the same situations. The only thing right now, we have the positive pointed up. Here's the pointed up. So I have, since negative, it should be pointed down. So from here, we're gonna be pointed down. Here is my force. So in that case, here is pointed down, and here will be pointed up. So now we see the positive charge. Any positive charge will be go up, and any negative charge will be go down. And that's something what we call the emotional EMF. And if you just make a generalize to just one single positive or negative charge, and you see that all the positive charge will be go up and all the negative charge will be down. And from here, they create the magnetic field. And it's going to be continuous, the situations here, until we get the same number of the positive charge, go to the negative or the number of the negative charge, so we call it the polarization. We have the same. And basically that we can apply that concept here for what we have in the battery. So basically what we have in the battery with the conductors, we have the positive charge in the positive terminals, and we have negative charge in the negative terminals, and we have electromagnetic field. So they create that what we call it the electric potentials. So basically that's exactly what happened inside the battery. So you apply the battery used to generalize or to generate a current or to feed the electric current. So what we call it here is the EMF. That's the source name for it, which is basically just the source or the basically we're talking about the EMF. It's basically we're talking about the electric potential, the potential difference, delta V. That's the same concept. As a general definition for the emotional EMF, it's just the voltage source created when the conductors moving in magnetic field. And this is voltage source driving a current. That's what we end up with. I have a different or the potential difference, and that generate the current that feed the electric circuit. So based on this concept here from the previous two slides, we are given here is the magnetic field, and this magnetic field right now is pointed out of the page, and we drag the conductors with the velocity up in all the situations, and according for that motions and magnetic field, what we expected, where is the positive charge will be and where is the negative charge will be, which side. So I give you a minute to think about it before we continue. You can pause the video. Now, basically, I will use the right hand rules. Here's the my right hand rule. The velocity pointed up and the magnetic field point out of the page. And what we end up with the force, positive force is going to be pointed to the right. And when I have positive force point to the right, positive force point to the right, in that case, what happens for the negative charge? Negative charge will be going to the left. So here is the negative charge, and here is the positive charge. So from that case, this is the figure E. That's the right representation for the direction of the positive and negative charge forces. Okay, it's enough for this lectures here. We're going to continue in second lectures to cover the material from chapter 25. Thank you.